Hello everyone, through this video we are going to discuss some of the important questions of exercise 4.5. Here I am starting with question number 12. So what is given here? Let A is equal to a 2 by 2 matrix is given here, then B is also another 2 by 2 matrix. We have to verify that inverse of the product of A and B is equal to B inverse into A inverse. So it is very clear that we have to find out individual inverses of the matrices A and B and then product AB. That means we have to find out inverse of A, inverse of B, and at the same time inverse of AB also, for getting this left hand side. And for right hand side we have to find out product of B inverse and A inverse. So here we start with, let us first find out the inverse of A. We have A is equal to 3, 7, 2, 5. Its determinant value is 15 minus 14. Answer is 1. And its adjoint will be, actually this is not equal to 0, so it is possible for us to get the inverse of this matrix A. Now adjoint of A can be evaluated by following this rule. These two terms will have to be interchanged, means I have to write here 5 and in this place I have to write 3. And in case of these two elements I have to make sign change. So in what way I shall have to write? I shall have to write like this, minus 7 then minus 2. So this will give us the adjoint of A. So its inverse will be, therefore A inverse will be equal to 1 by determinant of A into adjoint of A, that is equal to 1 by 1 into 5 minus 7 minus 2, 3, and our answer will be this matrix only, 5 minus 7 then minus 2, 3. So here is A inverse. So after this we shall come to the matrix B. Again we have capital B is equal to, let us write down the matrix for B. It is 6, 8, 7, 9. Let us first calculate its determinant value. Determinant of B is equal to 54 minus 56. The answer is minus 2. So this is again not equal to 0. At the same time let us find out adjoint of B, which is equal to, like the previous part only we have to do A11 and A22. These elements will have to be interchanged like 9 and 6, and the remaining elements there will be sign change. So this is adjoint of B. Therefore B inverse is equal to 1 by determinant of B into adjoint of B. So the result will be equal to 1 by minus 2, it is 9, minus 8, minus 7 and 6. This can further be written as, everything if I put inside, it is minus 9 by 2, means each and every term of this matrix if I multiply by scalar minus 1 by 2, the result will be like this. It is 4, then it is 7 by 2, and then here I get minus 3. So this is the result for B inverse. So after this let us now evaluate the right hand side, because the values for right hand side already we got B inverse into A inverse. So let us put the values, minus 9 by 2, here it is 4, then here it is 7 by 2, and I get here minus 3. Then A inverse, the result I got as 5 minus 7 minus 2, 3. 5 minus 7, 5 minus 7 minus 2, 3. Now let us evaluate. We already know matrix multiplication, so it is minus 45 by 2 minus 8. Then after it is 63 by 2 plus 12. In this part it will be it will be 35 by 2. So it is 35 by 2, then plus 6. Then after in the later part minus 49 by 2 minus 9. So after complete reduction we should get the result here as 61 minus 61 by 2, then in this case 87 by 2, then after I should get here 47 by 2, then after it should be minus 67 by 2. So these are the results I got for RHS. After that, next we need to get what is AB. So first we find out the product. AB will be the product of the matrices A and B individually. So means individually we have to write these two, 3, 7, and then find out the product. So here it is 2, 5 into, I get here 6, 8, 7, 9. Then after what we get 18 plus 49, then after 24 plus 63, then after 12 plus 35, then 16 plus 45. The answers will come like 67. Then after this is 87. Then after I get here 47, and in this case it is 45 plus 10, 55 plus 6, it is 61. Therefore let us find out its determinant value. Determinant of AB is equal to 67 into 61 minus 87 into 47. So our answer will come like 4087. 4087 minus 4089, and our answer is minus 2, which is not equal to 0. Therefore AB whole inverse exists. After that we shall have to find out adjoint of AB. So like the previous one, first interchange. So 61 will come first, 67 will come here, then minus 87, then after minus 47. So this is the adjoint of this matrix AB. So AB whole inverse. Let us check what result we get. 1 by determinant of AB into adjoint of AB. So after this we shall be getting 1 by minus 2. Then after we need to write 61 minus 87, then minus 47, then 67. So after this we get the result is 61 minus 61 by 2, then 87 by 2, then after 47 by 2, then after minus 67 by 2. Now let us check whether this is similar to the previous result or not. Yes, this is same with the previous result, that means RHS. So this is the result we got for the left hand side. So here actually I need to write left hand side. So this is the answer. Since LHS equals to RHS, hence proved. The next important question is question number 13 of this exercise. What is given here? If capital A is equal to, this is the matrix given, 3, 1, minus 1 and 2. After that, show that A square, capital A square minus 5A plus 7I is equal to a null matrix. Hence find A inverse. So while solving this question, actually in this question there are two parts. First we have to show that this expression is true. For that we need to find out what is A square. So here capital A is equal to 3, 1, minus 1, 2. Therefore A square is equal to A into A. That means we have here 3, 1, minus 1, 2 into, I get here 3, 1, minus 1, 2. While finding out the product, let us check what we get. 3, 3 ja 9, minus 1, then after again 3 here, plus 2, then I get here minus 3, then minus 2, then again I get here minus 1 plus 4. True matrix multiplication. So after this, what did I get? The result comes as 8, then 5, then minus 5, then after 3. So this is the result for A square. Now we have to show that capital A square minus 5A plus 7I is equal to null matrix. So we proceed with the LHS. In the LHS we are getting A square minus 5A plus 7I. Let us put the respective values. In place of A square, we can put the value which we obtained just now, 8, 5, minus 5, 3, followed by minus 5. In place of A, the given matrix we need to write, and that is 3, 1, minus 1, 2, minus 1, 2. Then after into 7, then here I is nothing but the identity matrix of order 2, 1, 0, 0, 1. And then after, while simplifying, we shall get 8, 5, minus 5, 3. Then after minus, what do I get here? 15. Then after 5, then after minus 5, then after 10 here, plus 7007. Then after performing complete simplification, the answer to be obtained here is ultimately 0, then after 0, then again 0 here, then after what do I get? Again 0. So ultimately this gives result of a null matrix that is equal to the right hand side. So the first part is already proved. Now coming to the second part of this question, there is a technique of solving the second part of this question, and that is what? Second part is what? To find A inverse. So we shall try to find out A inverse from this expression given. That is what we already have, and we have already proved that a square minus 5a plus 7i is equal to null matrix. So what do I do here? For finding out A inverse, we can do one thing. On both the sides, if I split it up, I get A into A minus 5a plus 7i is equal to null matrix. If I multiply both the sides by A inverse, I mean each and every term if multiplied by A inverse, let us check what do I get here. A inverse. This is called post multiplication, means each term should be multiplied by A inverse, and behind each term we have to place it, not in front. And if I put it in front, then on both sides the same thing should be done. So here I get 5 A into A inverse plus 7 I into A inverse, that is equal to null matrix, because this null matrix, if I multiply by A inverse, then ultimately the result will be a null matrix only. So here just by the side I can write post multiplying by A inverse, post multiplying by A inverse. So this is the way I can write it, post multiplication by A inverse. Post means after, means in each term we find A inverse after the term actually. So here I get A inverse minus 5, this will be I, plus 7 I into A inverse is A inverse only, that is equal to null matrix. So here I find A into Y, and this will ultimately give us the result of A only. 5i plus 7 A inverse equal to a null matrix. Now what would I prefer to do is, I shall keep A inverse alone in one side, and the rest of the terms will be shifted to the opposite side in the way 5i minus ai. So after this, what do I do? After this, 7 A inverse equals to 5 in the respective places. In matrix form I can substitute the values 1 0 0 1. Actually our intention is to derive the value of A inverse. In place of A, actually I can place here directly A and not I, because A into I is A only. So in place of A I can put here 3 1 minus 1 2, 3 1 minus 1 2. This is the value of A. After this, let us check what we get. This is equal to 5 0 0 5 minus, it is 3 1 minus 1 2, and after this what did I get? 7 A inverse is equal to, the result comes as 5 minus 3, it is 2, 0 minus 1, it is minus 1, then it is 1, because 0 minus minus 1 ultimately positive 1. Then 5 minus 2, this comes as 3. And then after, I have to make this term A inverse independent of 7, and I can write like this: 1 by 7 into 2 minus 1, 1, 3. If I want, I can carry this scalar term to the inner part of this matrix and can write like this: A inverse is equal to, each and every term of this matrix could be multiplied by 1 by 7, and the result comes like 2 by 7, then minus 1 by 7, then here I get 1 by 7, and this is 3 by 7. So this is the required answer of this question. After that, the next important question of this exercise, and that is question number 14. Let us see what is the question given here. For the matrix capital A is equal to 3, 2, 1, 1, find the numbers small a and small b such that capital A square plus small a into capital A plus small b capital I is equal to a null matrix. So we can directly evaluate what is A square and then find out, actually those values I can put in this expression and the answer will come. So given capital A is equal to 3, 2, 1, 1, let us find out what is A square. So let us put the value here, 3, 2, actually one more thing I must have to write here, and that is what? In between A into A I need to write. That shows multiplication of two matrices, that is A and A into A. Then after, what do I get? After this I can put 3, 2, 1, 1 in place of A. The same thing should be repeated for the later part, 1, 1. Then after, what answer do I get here? Let us check. 3 3 ja 9 plus 2 1 ja 2, it is 11. Then after, 6 plus 2, it should be 8. Then after, 3 plus 1, this should come as 4, and here it is 2 plus 1, this should be 3. So this is the result for A square. Now let us come to this expression now. I need to evaluate what is small a and small b. Now I prefer to write the expression once. We have A square plus small letter a into capital A plus b into capital I equals to O. In place of A square, what can I write? 11, 8, 4, 3 plus A, then after 3, 2, 1, 1 plus B, it will be 1, 0, 0, 1. This is identity matrix of order 2. Now we shall try to minimize the left hand side of this expression, and let us check ultimately what result we get combining all these three parts. Actually one more step I have to write down here to get this expression in more simplified form. Plus it should be thrice A, then twice A, then A, while at the same time I can write here B 0 0 B, that is equal to O, means null matrix. And in this side I shall be getting 11 plus twice A plus B, while in this part 8 plus twice A, yes, 8 plus twice A only. Then here in this case 4 plus A, then after in this part it is 3 plus A plus B, that is equal to null matrix, means it is a zero matrix of order 2 by 2. By condition of equality of two matrices, what do I get? By condition of equality of two matrices, we get 11 plus twice A plus B is equal to 0, comma, actually corresponding elements on both the matrices will be equal. 8 plus twice A is equal to 0. So from this part itself I can get the result, twice A equals to minus 8, so A becomes minus 4. This value if I put in 1, say this is 1, so this value if I put in 1, what result do I get? 1 implies 11 plus 3 into minus 4 plus B is equal to 0, and our answer comes here, minus 1 plus B equals to 0, and that further implies B is equal to 1. So these are the results, and from this could be verified with the remaining 4 elements. This position, for this position what can I write? 4 plus A is equal to 0, and 4 plus A is equal to 0, which can imply A is equal to minus 4, and from the last extreme end 3 plus A plus B. Also 3 plus A plus B comes as 0, and I can write here 3 plus minus 4 plus B is equal to 0. This further implies B is equal to 1. So finally, therefore, we get A is equal to minus 4 and B is equal to 1, and this is the required answer. Then coming to the next question, question number 15 here. This is another very important question. For the matrix capital A is equal to, matrix is 1 1 1, then 1 2 minus 3, then after 2 minus 1 3, show that capital A cube minus 6A square, 6 capital A square plus 5A plus 11I is equal to a null matrix. Hence find A inverse. This question is very important from examination point of view. Again, there are two parts here. So this question is again similar to question number 13. So in the same way we shall try to proceed here. Given A is equal to 1 1 1 1 2 minus 3, then 2 minus 1 3 I get here. Then after, actually for proving this expression we need the values A square and A cube. So once we get A square, it will be possible for us to find out what is A cube. A into A. So let us put the values in the respective places. 1, 1, 2, minus 3, then 2, minus 1, 3, that is multiplied by 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. After this, let us check what result we get on matrix multiplication. So the results to be obtained here are 1 plus 1 plus 2, it will be 4. Then after, in the next case, 1, 2, minus 1, the result will be 2 here. Then after 1, minus 3, then plus 3, the result will be, of course, 1. Then in this case it is 1, 2, minus 6, that means minus 3 it should be. Then after 1, then 4, it will be 5, plus 3, it is 8. Then after, the next result we should get as 1, then minus 6, then minus 9. Yes, the result should come as minus 14. So this is minus 14 here. And coming to the third row, what do I get? 2, minus 1, plus 6. Result will be 7. Then in this place the result comes as minus 3, and for the last one it will be 14. The result comes as 14 here. After this, we cannot stop here. Next again, a cube we need to find out, which can be found out using this form. So in place of a square, we need to write this expression 4, 2, 1, which we obtained just now, minus 3, 8, minus 14, then 7, minus 3, then 14. Then after, in place of a, we can put the values 1, 1, 1, 1, 1, 1, then 1, 2, minus 3, then after 2, minus 1, 3, 2, minus 1, 3. So this is the form we got. Then on matrix multiplication, the result to be obtained, these calculations you can complete yourself. So after complete reduction, the result should come as, first result should be 4, 2, 2, it should be 8. Then second one should be 7. The third one should come as 1. Then after, here I should get minus 23. Then after it is 27. Then here the result should come as minus 69. And then it should be 32. Then minus 13. Then 58. Yes, 58 I should get here. 7, then minus plus 9, 42. Yes, answer should be 58. Now these values we are going to put in the expression to be proved here. So to the question we need once again to show that a cube minus 6a square plus 5a plus 11i is equal to null matrix. So starting with the LHS, a cube minus 6a square plus 5a plus 11i. So in place of a cube, just now whatever result we got, that we can place 1, then minus 23, then 27, then minus 69, then after 32 minus 13, then after 58, then after minus 6. In place of this I can put 4. The result of a square we got as 421. 421, 10 minus 3, 8 minus 14, 8 minus 14, and then 7 minus 3, then 14. Then after, in place of a, I can put here 111, then 1 2 minus 3, 1 2 minus 3, then after 2 minus 1 3, 2 minus 1 3, and for 11i, order 3 identity matrix 1 0 0 0 1 0 0 0 1 I can put here. So after this, after complete simplification, let us check what result do we get. Minus 23, then 27, minus 69, then 32, minus 13, then 58, then minus. Here I get 24, 12, 6, then minus 18, then 48, then 84, minus 84, then 42, minus 18, then 84. These are the results I got. After that, plus 5, 5, 5. After scalar multiplication of this matrix by 5, I got this result to minus 15, then 10, then minus 5, then again 15, plus here I get 11 0 0 0 11 0 0 0 11. So after this, what do I get? Again simplification is needed. After simplifying of this these terms, ultimately we should get actually we shall be getting on simplification 0 0 0 all zeros. Ultimately we are going to get, which gives us a null matrix, and that is the required right hand side. So this is the result we got for the first part. Then coming to the second part, let's come to second part. The second part is what? To find A inverse. So we already have this expression, whatever expression we proved just now. With the help of that expression only, we shall be finding out value of A inverse. In exam, if this type of question is asked, you do not have to find out value of A inverse separately using adjoint and all. From this expression itself, this could be evaluated, but before going to the main step, you have to multiply both the sides by A inverse, either by pre-multiplication or by post-multiplication. So here in this case, multiplying due to the process of post multiplication on both the sides, what do I get? A square means 1a I am taking from here, then A inverse. Both the sides, each and every term I am multiplying by A inverse. That is also post multiplication. A inverse plus 5 A inverse. Why am I keeping 1a with A inverse? So that After putting this and the things in this way, I get the identity matrix I. 11 I into A inverse. Null matrix, if it is multiplied by A inverse, the result will ultimately be null matrix only. Post multiplication by A inverse. So what do I get here? A square into I minus 6ai plus 5i plus 11 A inverse equal to null matrix. And then I get only A square minus 6a plus 5i plus 11 A inverse equals to 0. Our intention is to derive only the value of A inverse, and for that A inverse means the term containing A inverse we should keep alone in one side, while the other terms, all the other terms should be shifted to the opposite side. So 11 A inverse I am keeping alone in one side, and the rest of the terms I shall carry to the opposite side. So this is the form I am going to get here. So what do I get? 11 A inverse equals to 6. In place of A, what can I put? 1, 1, 1. Then after 1, 2, 1, 2, minus 3. Then 2 minus 1, 3. 2 minus 1, 3. Then the value of A square is, value of A square I get as 421 minus 3 8 minus 14. Then after 7 minus 3 14. 7 minus 3 14. And then after minus 5 1 0 0 0 1 0 0 0 1. So let us simplify this part now. On simplification, what do I get? 11 A inverse equals to, I get here 6, 6, again 6 here, then 6, 12 minus 18, then after 12 minus 6, then 18. Then after this one will remain as it is, 4 2 1, then minus 3 8 minus 14, then 7 minus 3 14. Then here I get 5 0 0 0 5 0 0 0 5. On complete simplification, what result do we obtain here? We get 11 A square is equal to, then 6 minus 4, this result will come as minus 3. Then after 6 minus 2, it is 4, so this will become 4. Then 6 minus 1, it will become 5. Then 6 plus 3, ultimately it is 9. So here the result comes as 9. Then after 12 minus 8, it is 4. Minus 5, this result will be minus 1. Then after minus 18 plus 14, the result comes as minus 4. So, and the last three values are 5, and then I get here minus 3, then 18 minus 14, it is 4, minus 5, it is minus 1. Now for getting A inverse, I have to make this term independent of 11, and that will come to the opposite side as reciprocal. So 1 by 11 will be getting multiplied with this already derived matrix 9 minus 1 minus 4, then 5 minus 3 minus 1, and Finally, this is the answer to be obtained. Thank you.